The following is an explanation of example 5.13 out of the textbook on page 204. We're given a sample of methane with a volume of 2.80 liters at a temperature of 25 Celsius and a pressure of 1.65 atmospheres. This methane is then mixed with a sample of oxygen with a volume of 35 liters at a temperature of 31 Celsius and a pressure of 1.25 atmospheres. This mixture was ignited to form carbon dioxide and water. Calculate the volume of carbon dioxide formed at 2.50 atmospheres and 125 Celsius. From this question, we need to determine our reaction. Methane is CH4. We're reacting it with oxygen to form CO2 and H2O. I'm going to go ahead and balance my reaction. The states of matter are all gases. So this is a true gas stoichiometry question because we're only working with gases. Now we need to figure out what the question's asking us and what the question's giving us. I'm going to highlight information about methane in yellow, information about oxygen in pink, and information about carbon dioxide in blue. So the information about methane is that we have a volume of 2.8 liters, a temperature of 35 Celsius, and a pressure of 1.65 atmospheres. The information I know about oxygen is that we have a volume of 35 liters, temperature of 31 Celsius, and a pressure of 1.25 atmospheres. And what I know about carbon dioxide is that I have a pressure and a temperature. I have a lot of information about methane and oxygen. In fact, I have the same information about methane and oxygen. I have volume, temperature, and pressure. The only thing I'm missing is the number of moles. If I know that much information about these two compounds, then I'm going to have to end up picking between the two, making this a limiting reactant question. I'm going to go ahead and work with my methane first. And just to clarify, I'm going to keep it highlighted in yellow. I have a volume equal to 2.80 liters, a pressure equal to 1.65 atmospheres, and a temperature equal to, I don't like 25 Celsius, I'm going to go ahead and add my 273 to that, and I get 298 Kelvin. I can go ahead and take my PV equals nRT, rework it so that N is by itself. I get 1.65 times 2.8, that's my pressure times volume, divided by 0.08206 R, and my temperature, 298, and I will get 1.89 moles of methane. I'm sorry, not 1.89, 0.189 moles of methane. Now I really don't care too much about my moles of methane. I would rather convert it into what the question's asking me about, which is CO2. And there's a 1-to-1 ratio for my balanced equation, and I get 189 moles of CO2. Now I still haven't touched my values for oxygen, so I'm going to go ahead and copy those down. I have a volume, I have a pressure and a temperature. My volume is 35.0 liters, my pressure is 1.25 atmospheres, and my temperature converted into Kelvin is 304 Kelvin. And I'll go ahead and highlight that O2 in pink just to keep things consistent. Now, since I want to find moles of O2, I'm going to use the exact same format of my PV equals nRT, just subbing in my new values for pressure, volume, and temperature. So there's my pressure, my volume, 0.08206 is R. That does not change. And my temperature is 304 Kelvin. I plug this all into my calculator, and I get 1.75 moles of oxygen. Except again, I don't like oxygen. I'd rather have carbon dioxide. And for my balanced reaction, I get a 1 to 2 ratio. So I need to take that 1.75 and divide it, and I get a value of 0.875 moles of CO2. I look at those two numbers, and the one that is least is the one that I want. So that is the true value for moles of carbon dioxide. However, I have not quite finished answering the question. Calculate the volume of CO2. But now that I have moles with my atmospheres and with my temperature, I can plug it into PV equals nRT and get an answer. So I have CO2, I've got a pressure, a number of moles, and a temperature. My pressure, right out of the question, is 2.50 atmospheres. My number of moles I just determined to be 1.189 moles. And my temperature converted into Kelvin is 398 Kelvin. Plugging this into PV equals nRT, but solving for V, I get V equals nRT over P. Plug in my numbers, V equals 0.189 times 0.08206 times 398 divided by 2.5. I get a volume equal to 2.47 liters. Now that was a bit of a marathon problem. We had to work with a changing volume. We had to work with changing pressures. There were no shortcuts. However, if we just take our time, we'll be able to get the right answer. Again, this is example 5.13 off of page 204.